Hi everyone, Mario here. In today's tutorial we're going to continue on with our Asteroids game. In this session we're going to be working on rotating our player, accelerating and stopping our player, as well as tweaking each of the players to accelerate at different rates based on their speed attributes. Let's get stuck in and look at what we're going to be building. So this is the Asteroids game that we left off with our player select screen. You can see each of the three fighters have a different speed attribute. And in this session, we're going to use that speed attribute to tweak the acceleration of each of those fighters. So I'm going to press enter on this center one here. So you can see now we launch into the game. I'm holding the up arrow and you can see that I can fly my fighter around. You can see it reappears on the other end of the screen. I can go in reverse as well if I hold the up arrow. And if I stop holding the key, you can see that the fighter does slow down eventually. The different fighters go at different speeds, so their top speed's all the same, but their acceleration is different. So you can see the smaller fighter is a little bit slower. So let's go have a look at some code and start building this. This is where we left off our Asteroids game in our last session. Let's run it and see what it looks like. So we've got our player select and we can select our player, but when I press enter, when I press return, nothing happens. So the first thing we're going to do is make it so that when you press enter, it's going to select our player and it's going to start our game. Let's get stuck into some code. So we're going to need to respond to our enter key here. So when we press our enter key, we're going to do something. So I'm going to add a new switch to our case here. And for the enter key, it's actually the return key here. If we put enter, it won't work. And the first thing I'm going to do is just clear the screen of everything because we're going to want to redraw a new screen for our game. So let's run that and see what happens. So I'm going to press enter and we've cleared our screen. Excellent. So the next thing we're going to do is we're going to create a new screen class to hold all the logic for the game. So we've got our player select screen, which is going to be, which we used for just the player select, and we're going to need a new class now to handle everything for our game. So let's head over to the player select screen. So I'm just going to head to the bottom of the player select screen here. We're going to create a new class and it's just going to be called game screen. Okay, and this variable here we might rename because we're going to hold the current screen and we're going to do different things based on if we're looking at the player select screen or the game screen. So all of these we will replace with current screen. Okay. Now this existing logic here, I only want this left, right, and this return to happen if we're on the player select screen. So I'm going to put some logic around this. So I'm going to say when it's the player select screen, then case current screen. Okay, so when our current screen is a player select screen, then we can run this logic. If it's not, then we're not going to execute these things. Once we clear the window, we want to replace the current screen with a new instance of our game screen. So let's do that. So current screen equals game screen.new. Now let's run the program. So I'm not expecting it to work because we haven't implemented anything on our game screen, but we should get an error saying, what we're missing on our game screen. So I'm going to select this one here. I'm going to press enter and you can see that the error we're getting is undefined method update for game screen. So in the loop here, we're calling update on the screen. Now that we've got our game screen, we need to create an update method. So doing this should fix our error. Now our game screen, we want to have a few of the same things that we have on our player select screen. For example, the stars, we want to draw the same stars. So I'm going to pinch some code here. This initialize we're going to take and we're going to create a new set of stars to render out. So this I'm going to take and put into our game screen. And then during the update, we're going to move the stars. So I'm going to copy this update logic as well. Okay, let's select our player. And now we get a new set of stars. So they're not going to be exactly the same as the player select screen, but I don't think that's too noticeable. But that's looking good. So the next thing to do is to draw out our player. So the good thing about the player is we've abstracted a lot of the logic around how that works to its own class. And so we can use that class from our new game screen. To do that though, we need to get some information from the player screen. So we need to know what player that you've selected. So we're going to need a new method on our player select screen, which is going to return the currently selected player. So we've got this variable here, selected player, and this instance variable holds which player we've selected. So as you press left and right on the select screen, this value will change. So we need to take this value and then look at which of the players that we have. So if, for example, the selected player is 0, the first element of the array, then we want this. If selected player is 1, this one, and 2, we want to get access to this. So I'm going to add a new method to the player select screen. And what that'll do is it'll return the player that we're interested in. So let's add it to the bottom here. So I'm going to call it selected player. And what we're going to do is we're going to look at our players array, and then we're going to return the one that is currently selected like that. So this method should return a player object. So to our game screen now, we can pass in that player object from the play select screen before we replace it. So I'm going to say game screen.new, and I'm going to pass in the current screen's selected player, that new method we just made. And now we need our game screen to take this in its initializer. So in the initialize, we take in a player, and then now we can create a new player based on a lot of those properties. So here I'm going to hold on to a player. So because we're clearing the screen, we can't use the same player. So I'm just going to create a new one with a lot of the same properties. So a few things for the player. Let's have a look and see what information we need. So for the player, we need image, XY, speed, and fire rate. So XY, speed, and fire rate are already available on the player, but the image is not. So we need to expose this so we can create a new player based off that. So I'm going to take the image here, and we're going to hold on to our image as it comes in. Cool. So we should be now able to create a duplicate player with all of the same properties as the one from the select screen. Great. Okay. So here we go. So now on our player instance, we can pass in a few of the information, few of the bits of information we need. So the first one is just the image. So I'm going to grab that from the player. We've got the X and Y, and then we've got the speed and the fire rate. Okay. So I hope that matches up. Let's just check the player. So image, XY, speed, and fire rate. Image, XY, speed, and fire rate. Okay, let's see if that works. Okay, I'm going to select the middle one, and that's awesome. So it's in the exact same spot, which is good. We've got a new set of stars. Let me run that again and see if I can select one of the other players. That's great. And the good thing is, because we're reusing the X and Y positions, they spawn in the same spot as the select screen. Awesome. So we might just throw on the animation on the back, even though it's not moving. I think we'll use the slow animation that we created last time. So that should just be as simple as calling the animate slow method on our player, which will animate it there in a loop. So it should just be player.animate slow. Awesome. That's looking great. Next thing we're going to do is we're going to allow the player to rotate when you press the left and right keys in a circle. So let's get to that. We're going to need to listen to some key events. Now we're using key down, so that event will fire once when you press down the key. But in case of the rotating, we actually want to continuously rotate. So it's a bit easier if we just have an event that fires continuously as we hold down the key. And there is an event we can use in Ruby 2D called key held. And this will trigger multiple times, and it means that we can rotate our player by a little bit each time that event is fired. Our event, we only want to run it when we're on the game screen, not the player select screen. So we need to check that first. So we're going to do the same thing, case current screen, and we're only going to run this code when we're on the game screen. Then we'll check the event key, and we're interested in the left key. And also the right key. Okay, so when we are pressing left, we're going to rotate left. When we're pressing right, we're going to rotate right. Let's add this rotate player method to our game screen. Okay, so here we could put some logic to actually rotate the sprite, but we're not going to. Instead, we're just going to tell the player instance to rotate it for us. The reason why we want to do that is this is the actual sprite that we want to rotate. We want to change this starting 180-degree value. And at the moment, there's no reader, there's no way for us to access that information outside of the player. And that's kind of a good thing, because instead of reaching into the player, getting its sprite, and then mutating it ourselves, we can simply tell the player, can you please rotate? And then it will rotate its sprite. It means that any logic associated with this sprite is just in this one place, and it's not going to be scattered through the application. And it should make it easy for us to deal with that. So here in our method, we're just going to call player.rotate, and then we'll pass in our direction, and we'll implement that logic now on the player. So we're going to rotate, it's got a direction. We're going to do a case on that direction. When it's left, then we want to take away, I think, from this value. Let's try that out. That's on our sprite. So it's going to be sprite.rotate take away 1. When it's right, then let's try adding 1 to our rotate. Okay. So you can see when I'm pressing left and right, it is rotating. It's a bit slower than I would like, so let's add a multiplier that we can then use to change how fast it rotates. I'm going to add a new constant next to these. Let's call it rotate speed, and I reckon about 5 times faster should be good. So I'm going to change this to rotate speed. Let's give it a go. Okay. So that seems to be working fine. I can rotate in either direction. Awesome. Next thing we're going to do is start accelerating the player in both the forwards direction and the backwards. So you'll be able to hold forwards, it'll start accelerating that way, and backwards in the reverse. Let's get to it. Okay, so much like the rotate, we're going to keep the logic all in the player class, it can rotate that, move that sprite itself for us. We're going to add some things here. So we're going to say when up and when down. Then the current screen can accelerate the player, and we want to accelerate them forwards if they're pressing up. And then when you hold down, it's the same but backwards. Let's change this. Okay, direction, and same thing here, player.accelerate, and then in the direction that we specify. Okay, let's implement our accelerate method. Okay, we've got two cases as well, which is our direction. When it's forwards, we'll do one thing. When backwards, we'll do another thing. We might just focus on the forwards to begin with, and then we'll do the back once we get it. So to implement our acceleration, we're going to need to do a little bit of linear algebra. So we're going to need to keep track of both the x and the y velocity of the player. Because when you press, for example, when you press the up arrow, we're going to need to change them based on where the player is pointing. So an example might be, let's say you're pointed out here. Well, you've got quite a large y velocity in this direction, and then a little bit like a smaller velocity in the x direction. So proportional to where you're pointing, we want to, the easiest way to be able to move our player is by having us remember the x and the y velocity and then moving them based on that velocity. There's a few tricky things that we need to deal with, like, for example, can we set a cap on the velocity? Otherwise they might be going very fast. We need to deal with the player leaving the screen and a few little things like that. But for the moment, let's see if we can just make a very simple bit of code, which will just track the velocity that we're putting in. So when the player starts, the x and the y velocity, x velocity will be 0, and then the y velocity will be 0. Just so we can see our player moving, I might actually give it a small velocity. And then we can work on moving the player each frame. So when the velocity is set, we need to actually move our player. So in our update on the game screen, we need to move our player here. So I'm going to say player.move. I'm going to make a new method called move on our player. And we'll use this x and y velocity to move our player. Okay. So after our accelerate, I'm going to say move, and we're just going to set the player, sprite, sorry, .x, and we're going to add on the x velocity, and then the same with the y velocity. And hopefully each frame our sprite should move a little bit. Okay, so you can see they're just crawling away. I put a very small velocity in, but you can see they're moving down and to the right as the x and the y coordinates of the sprite increase. So I'm going to set these back to 0 now that we know that works. And so the next step is to modify our x velocity and our y velocity based on what's happening here. So the key thing we're going to take in is this rotate. So that is the angle of the player in degrees. We're going to use some of the trigonometry functions that are provided by Ruby to take that angle in and then figure out the X component and the Y component, like I mentioned. The Ruby library does use, it doesn't use degrees though, it uses radians, so we do need to do a conversion to radians so that it will work. This took me a little while to get going earlier, so I'm going to pinch some code that I wrote earlier. So our X velocity, we're going to add on math.sine. So the sine will give us the X component of our vector. We're taking in the angle, so 180 degrees pointing down or 0 degrees pointing up. We're going to change that degrees into radians, so it will work with our Ruby sine function. So we're going to use pi divided by 180. And that should be it. So let's try the y as well. With the y, we actually need to use the negative. So we're going to take away math.cos. Cos should give us the vertical component. Okay, so let's try that out, see what happens. Okay, that was very fast. We might need to slow them down a little bit. So I'm gonna times this by a number that's less than 1. Let's say velocity increase speed. Let's do the same here, and we're gonna tweak this to get a number that's a bit nicer. Let's say 2, so 20% of what we just saw. That was very fast indeed. Okay, so I'm able to press the up arrow, and you can see that we're moving around. One thing is, it would be good to see when I'm actually pressing the up arrow, when the rocket's actually firing. So in the last session, we created a slow and a fast animation. So I think what we can do is play the fast animation when we are accelerating. So this animate fast here, when we call this accelerate, I'm going to call this here. Okay, looking good. Okay, so the one thing is I've let go of the keys. I'm not accelerating anymore, but we're still playing that fast animation. So it'd be cool if we can get that to stop when I've let go of the key. So we're going to need to trigger that. Okay. So we need another kind of key handler, and it's on the key up. So when I let go of the up or the down key, we want to do something. So we only want to do it when we are on the game screen, not on the play select screen. Let's check our key. And we want to do this when we're either on the up or the down key. So when either of these are pressed, then on the game screen we'll say stop accelerating player. And just like the other methods that we've implemented, we're just going to call that directly on the player. This time we don't have an argument because there's no direction to pass in. So let's call that stop accelerating player. And when we stop accelerating the player, we just want to play this slow animation. Okay, I've got a syntax error, line 268. Let's check that quickly. Okay, I think I might be missing an end here. Let's add that in. Try it again. Okay, so we've got an error, unexpected method, stop accelerating on the player. Did you mean stop accelerating player? I think I've made a mistake. This should be stop accelerating. Okay. Okay, it's not actually stopping. Why is that? Okay, this should be key up when we release the key, not key down. Let's try that one more time. Okay, you can see it working well now. So when I'm pressing the up arrow, you can see that the animation's playing. And when I let go of it, then you can see that it stops. So that's working really well. So at the moment I've got my forwards working. Let's see if we can get the backwards working. Okay, so the backwards is essentially the same as this, just in reverse. So we're going to take that away and we're going to plus that. Let's see if I can get that working. Okay, so I'm holding forwards now and now backwards. It might be nice to have a different animation for backwards. Could even have maybe the thruster reverse color or something. For the moment, that's okay, but yeah, I can go forwards and I can go backwards. It's looking really good. One thing we need to solve is just disappearing from the edge of the screen. So if I go all the way to the right, the player will go off. It's not going to come back. We've done a similar thing where we wrap around by just using the modulus. In this case, it's going to be a little bit different because if we just use the modulus, the player is probably going to disappear very soon. So as soon as the kind of nose, I think, of the player gets to the edge of the screen, that'll automatically reappear on the edge and it'll look a little bit jerky. What I think we should do instead is we should wait till the player's gone at least a little bit past the edge of the screen before we show them on the other side. So let's write some code to do that. So this is where we're going to modify our code to have that player reappear. We're just adding at the moment the x velocity and the y velocity, and it means that our x can get really, really high, or it can get really far below 0 and be off the other end of the screen, and the same with our y. So we're going to need to check them. And again, it's going to be a bit more complicated than in previous times where we use the modulus operator. So after we set our x and y, now I'm going to do a check. So I'm going to say if our x position is greater than window width, and here's where we need to add a bit of a buffer. So it's not so much that you've got to the end of the screen, but you've also kind of gone past a certain amount. And the extra padding I'm going to add is actually just going to be the width of our sprite. So here we've got these width and height values which we're setting on our sprite. So I'm just going to use this width and height as the padding. We might need to tweak this later just to kind of dial in the feel of it. Because the values we put here will be quite sensitive. So I'm going to say if it's greater than the window width plus the width of the sprite, so essentially once our entire sprite is off the edge of the screen, then we will reset our sprite to the other edge of the screen. So I'm going to say sprite x. So here, if I put in 0, it's going to reappear partway on the screen, and we want it to appear all the way off. So essentially on one frame it will completely disappear, and then on the next frame it'll start entering from the other side. So we do need to put it a little bit into the negative. And here's where I'm just going to use the width of the sprite again. Now, that's when the x is off the page to the right. When the x is off the page to the left, we need to do a slightly different check. So when our x is less than the negative sprite.width. So not only have you gotten to 0, but you've gotten to negative the width of the sprite. So all the way off the to the left, then we're going to do the same thing. So we're going to say sprite.x equals the window width plus sprite.width. And hopefully that should give us a smooth transition when we leave and re-enter. So I'm just going to point off the screen. You can see that the entire sprite disappears and it reappears. If you find on your version it's a little bit janky, like it's not completely lining up, then you can tweak these values rather than putting the sprite width. You could hard code a value in there just to play with it. So we need to do the same with our Y to make sure that we don't go off the page vertically. So it's the same code. I'm just going to replace width with height in this block, and then also X with Y. So I think that should be exactly the same. Otherwise, let's test it out. Cool. So you can see I'm able to disappear one way and then appear in the next. We can disappear this way and any combination. It's looking really good. The next problem we're going to address is the speed. So at the moment I've been going pretty slow, but if I want to, I can just keep on accelerating and accelerating and accelerating until it's pretty impossible to recover my player. So it'd be good to add a limit to the maximum speed we can go. And then we should be able to avoid that kind of scenario. Might just be a little bit nicer for the player. We're going to need to do that, we're going to need to tweak this code here. So at the moment, we're continuously increasing our X and our Y, and they can get to very large values, both in the negative and the positive. So what we want to do is we want to set a velocity limit. So we're going to say the maximum velocity is a certain number. And then we're going to get the total of the X velocity and the Y velocity, combine them together, and then see if we're over our limit. So just before we do that, I'm just going to pull this out. So we've rewritten that same code 2 times, and we are going to need these in 2 places. So I'm just going to extract this out. So I'm going to say our X component is that, our Y component is this. Okay, and now we can add our X component, Y component. Okay, let's see if that changes at all. Okay, still looks good. All right. So the next step now is to sum up the total values of this X component and the Y component. Sorry, not the X component and the Y component. We need to sum up the X velocity and the Y velocity. So because they can be negative or positive, we want to, if it's negative, we want to take the positive value. The way we can do that is in Ruby, there's a method called absolute, and that just changes any negative numbers into a positive. If it's positive, it just returns the same number. I can show you that really quickly here. So if I have the number 5 and I say the absolute, we get 5. If I have -5 and I call absolute, we also get 5. So that's super important for us because we want to limit the player in all directions. And if they're going, let's say, up and to the left, then the X and Y values will be really, really big in the negative direction. So let's work out our total velocity. So total velocity is the X velocity, the absolute of it, plus the Y velocity absolute. And now is the point where we want to check that total velocity and see if we've just gone over a limit. So I'm going to set something here. Let's call it max velocity. I'm going to set it to, let's say, 2 initially. We'll tweak it from there. And I'm going to say if our total velocity is greater than our max velocity, then we need to adjust our X velocity and our Y velocity to suit. So let's run through an example. So let's say our max velocity is, for this example, let's just say, yeah, so let's say 2. And our x velocity is, let's say 1.5, and our y velocity is 1. Then we've broken that max velocity if we combine these two velocities together. So our y is 1, our x is 1.5. So at the moment our total velocity is 2.5. We're over this max, so we need to reduce our velocity to fit into that envelope. But the thing is, we want to reduce these proportionately. So it's not enough just to lop off that extra 0.5. We also want to reduce the y in the same amount. If we don't, the player will start changing directions as we start limiting their velocity, which is not something we actually want to do. Even if you're at the max velocity, you should be able to change direction. So based on how you write this code, we could very easily break that, which we don't want. So what we're going to say is we're going to say our x velocity is the existing x velocity and then scale to match. So we're going to get our max velocity and divide it by the current total velocity. So that should scale our velocity if we're over. And I'm going to do the same for the y. Run the game. I keep on picking the center one. Let's pick this other one. Okay, I'm holding the up arrow. You can see it's very slow. We might tweak that max velocity a little bit, but you can see I can still change directions and it's limiting my maximum speed, which is really good. I'm holding backwards now, going in backward circles. So let's boost that number up. Let's try something like 10. Cool. So looks like it's working. We're still going pretty fast. It's not crazy fast where we can't control it. You can obviously tweak that value 10 to pick a value you like, but it's looking good so far. The next thing we're going to do in terms of this player movement is tweak the way each of the different players moves. On our player select screen, we set up this speed here, this first attribute, and you can see we've got 60% for this small fighter, 80 and 100%. What I think we should do is tweak the acceleration values. So this one, for example, will accelerate 60% of this one, and this one will accelerate somewhere in the middle. And that'll give us a unique feel for each of the different fighters. So each fighter has this speed value. That's going to be a number between 0 and 100. So we can make it so that the green one, the one that's 100, will just go the same speed as we've already seen, but each of the other ones will get a bit slower. So I'm going to actually multiply this value here, this x component, by that speed value. If we just multiply by the speed, it'll be 100 times faster, so we want to divide by 100. And we need to put the 0.0 there to make sure we get a partial number. Otherwise, it'll just be either it'll be a whole number, so 0, 1, which we don't want. So same for this. Okay, let's try that out. I'm going to try the green one first. It should be about the same as what we saw before. So this is what we see. The max speed. Let's try that white fighter now. It should be 60% of that. And that certainly seems a bit slower for me. Awesome. The fighter on the left should be somewhere in the middle. Okay. I think that's working. They're not so far off that it's super obvious, but it is a little subtle change. The last thing that I want to do is just decay the player speed. So we're in space, there's not a whole lot of atmosphere, but there is a little bit, so hopefully there's a little bit of friction around. And what I'd like to do is, at the moment, my fighter is just crawling very slowly. I'd like for it to eventually stop and stop in the one place if we're moving slowly. The way we're going to achieve that is we're just going to constantly be reducing the player's speed, but by a very, very small amount and by a percentage of their actual speed. So for example, if each frame we just say the player's speed will be 99% of the current speed, if you're accelerating, that's not really going to make much of a difference. You might accelerate 1% slower, but when you're not accelerating, it means that the player should kind of eventually stop in the one spot. So that's what we're going to do. So we need to do that each frame. So let's look at our game screen. So this update gets called on every frame. So we're moving the player, and we might slow them down after we move. So we might say player.slow down. Let's add this method to our player. Okay, I'm going to pop it here, and all we're going to do is we're going to change this x velocity and the y velocity that we've got here. Okay, and it's going to be the x velocity times, so we can say times equals 0.99, I think. That should work. Let's give it a go. Great. Awesome. So you can see it's going to eventually stop, but it's going to shave off 1% of the speed every time. So it looks like it's basically stopped there. So that's really cool. I'm going to accelerate a lot, and we should hopefully see a big decrease. So I've let go now, and you can see it eventually slows down there. So we can tweak this number here. If we wanted it to slow down faster, then we could take a bigger number. So for example, if we say 90% each time, it's going to really slow down very fast indeed. And in fact, I can see it does seem to interfere with the actual acceleration. So it's quite a lot. But if we use 99, then I think that shouldn't affect the acceleration much. The acceleration is nice and fast. But as I let go, you can see that eventually it does slow down, which I like. So the values that we've got here in terms of the speed and everything, we can tweak. One thing I might do is actually put this into a constant, just so we've got it with all these other values here. So I might say slow down rate equals 0.99. Okay, and it means that all of our values are here all together if you want to change anything. That's going to be it for this session. We've done quite a lot with the player movement. We haven't done anything yet with any asteroids or any shooting or anything like that. We have incorporated that speed value though, so each of those unique players' speeds are already being incorporated, and then when we do the asteroids, the firing rate will be different based on the ship you select. So I hope you'd enjoy that session today. I've had a lot of fun. I'll see you in the next one. Take care.